Hello everyone, Matt Rogers from Salisbury here. Today I'm wanted to talk about Unit 2, Lesson 12. We touched on this a little bit in a previous video, but I'm going to go through now that we've completed the lesson in class and give you some kind of ideas of what's going on in this lesson. So our key question is, how do I represent two-digit multiplication by two-digit multiplication using the area model? Area model is kind of our most basic starting block. It does take the most time, but it's probably the easiest way for the students to visualize the multiplication. So two parts to it were understanding the two-digit multiplication. The other was practice. In our first picture, or part of the activity, what we have is a problem up the top that more or less creates the equation 24 times 37. When we use the area model, we spent some time talking about 100 blocks, quick tens, and individual ones, and that, again, relates to what we're working on now. Along the top, you have the 37 times 24 in the top left and right-hand corner, or excuse me, top left corner. Okay? And with that, I'm just going to grab the highlighter. We expand it out as the tens, 3 tens, and 7 ones, and 2 tens, and 4 ones, or 20 and 30, 7 and 4. When I go ahead and look at this, again, very similar to kind of like a coordinate grid or multiplication chart, I count out by groups of 10. So out by 10, down by 10. And then I fill in the area. I know that 10 by 10, as shown right here, gives me 100. And I continue to do it for each of the groups of 10. So I know, again, for this one, it's another 10, and it's still a width of 10. So again, this is also going to equal 100. Alright, let me get that a little bit thinner. Again, finally, 10 by 10 is 100. That continues for 6 total boxes. Apologize for my lack of straight lines, but hopefully you get the idea. So, in all, when I look at all of these, it gives me 100, 200, 300, 400, 500, 600. So my first partial product is 600. Then I shift to my multiplication of 1 by 10. Well, in this case, I've got 7 across by 20. Each one is one individual. So 1, 2, 3, 4, 5, 6, 7. And it goes down by 10. So I know that 7 times 10 gives me 70. This is, again, another cross by 7. Down by 10, which would give me 70. I'm going to switch it up down at the bottom. It's going to be width of 4, length of 10. This is going to give me 40. Nope. Apparently autocorrect doesn't want it to be 40. And I'm going to have 3 boxes of 40. Still not a fan with the 40. I apologize. And this bottom box then is the remaining 1 by 1 digit multiplication. So 70 plus 70 is 140. 4 by Matthew. Sorry if we got chopped off there. I just got a maple bacon donut from our awesome principal and guidance counselor, so sorry. Where I was leaving off, and our marker's not necessarily working really well, but down here we have the 40, 40, and 40, which would give me partial product of 120. And I know I can handle 7 times 4, which gives me 28. When I add up all of my partial products, I get a total answer of 888. So, as we saw, we look at the hundreds, the 10 by 1s, and the 1 by 1s, and we have 4 partial products that we add up to give us 888. Now this continues with what we call the sketch model. So we talked about how they don't necessarily take the dot charts or the maps home with them, so they can create these sketches on their own. So still, I have a 30 by 20. Another way we look at it is, I know that I have 2 times 3 with 1 and 2 zeros. So 2 times 3 is 6, add this 0, add the second 0, you get 600. 20 times 7, well 2 times 7 is 14, add the 0. 4 times 30 is, well 4 times 3 is 12, add the 0, and then 4 times 7 is 28. And then I bring that over here to do my place value section method, again based off the area model, do our partial product equations, and then add up the answers. Alright? When we got into this activity, we talked about how we separate based off place value and the main number. So if I have 20 by 30, all 4 of these equations add up to each of the partial products. So this will end up being one whole project. But 20 times 30, I know essentially is 2 times 10 by 3 times 10. If I separate number from place value, I have 2 times 3 and 10 times 10. In this case, 2 times 3 is 6 and 10 times 10 is 100. So our answer is 600. Similarly, 600. 20 times 7 is 2 times 10, which gives it the 0, and 7 times 1. If I take the numbers, 2 and 7, and multiply them, and then the place value, 10 and 1, I've got 14 and 10, which gives me a total answer of 140. Down below, 4 times 30, I know 4 times 1 and 3 times 10. If I take the numbers, 4 and 3, and then I do the place value 1 and 10, I've got 12 times 10, which gives me 120. And lastly, 4 times 7, 4 times 1, because it's in the 1's place value. 7 times 1, also in the 1's place value. So I take the numbers and I get 4 times 7, which gives me 28, and 1 times 1, which gives me 1. 28 times 1 is 28. So again, these are the 4 partial products that we talked about earlier. So, when we're done that, we add them all up. Now this is a lot of work, but again, it may make more sense to your student. Down below, we continued with some other practice activities that use the same methods, and the kids had the opportunity to either use the exact chart, or they could do the sketch or the place value section method. Hopefully this was helpful. I know it went on a long time, but this is what we covered when we moved into 2-digit by 2-digit multiplication. Let me know if you have any questions.